Hi, good morning. Today we'll be discussing about the uh, software technologies, software frameworks for building applications like Spring Boot framework, microservices, design patterns, and middle layer, database layer. We'll discuss few concepts in this podcast. So, first thing is, we all know the Java programming is playing a key role in developing applications, building applications, but the Spring Boot is a very good framework. Nowadays, for faster development of the applications, everybody is using a Spring and Spring Boot framework. I already explained what is a Spring in earlier video, what is difference between Spring and Spring Boot. You can see the differences there. Spring Boot is nothing but an extension of the Spring framework. It is providing auto configuration, simplified annotations, embedding boilerplate code, embedded servers, externalized configurations, logging, and actuators. So many features were coming up with the Spring Boot. So that is why Spring Boot is most used framework and most advanced for now, because even for building microservices architecture also uh, the people and teams they are using the Spring Boot. Okay, so what do you mean by Spring Boot here? Spring Boot is nothing but external tool. It is a framework extension to the Spring. It gives starter dependencies. The first thing is it comes with the starter dependencies. What do you mean by starter dependencies? Starter dependency is nothing but a dependency which is composed of many dependencies. All subsequent interrelated dependencies will be clubbed together and it will be formed as a one dependency. When you mention the dependency inside your build file, if you are building with the Maven, you can consider pom.xml. Inside the pom.xml, if you specify simply Spring Starter uh, web dependency, it will download all web related for building a web application. What are all the dependencies you require? So all those dependencies will be downloaded automatically. You don't need to specify each and every dependency that are required to build a web application. I hope you understand what I'm telling you. For example, if you're dealing with the data, Spring Starter data dependency is there. If you're dealing with some other some other third party, you can specify third party dependencies also. So starter dependencies are very good concept. Developer is not going to take any pain when he is going to deal with the um, development approach. Okay, that is the one thing. Other thing is embedded server. Earlier when we develop applications, we will generate enterprise artifact or war web archive artifacts, and then we will deploy them in server separately. But here you can develop a code and you can run a Java that Spring Boot application, the complete API, the complete project, complete multi-module project. Also, you can run it as a single standalone application that is there. So you easier testing, you can easily test it. There is a flexibility. Okay, you can do all these things with Spring Boot. Other thing is external configuration. So we can actually specify all the configuration in third party server, some git repository somewhere else, and you can actually fetch those on fly when you are building applications, and you can actually configure those your application. For example, I have some server related data, some data source related, some queue management related data, some environment details I need to use. You can specify all these things in your property file. You can place this property file in some Git repository. Okay, and then I will create a uh, config server in a Spring Boot using some annotations enabling at the rate config server annotations, and whatever the service I'm going to create, I'm going to mark it as a client. I have to register this client with this my server. Then automatically through the server, I'll fetch all these. It will fetch all these properties, and it will use them in your respective subsequent microservices. So it is one of the good example. You can actually utilize all the external services, external configuration concept. You can actually fetch all the external properties on fly when you are building an application. So that is also a very good example. One of the best features. Other thing is actuators is also one good concept. Before that, I want to discuss Spring Data JPA and profiles. Profiles is the concept where you want to deploy an application in multiple regions, right? Then you may require to configure different properties for staging region, for production server, dev region. So they'll change from region to region. The properties will change. How do you configure? How do you dynamically, you know, access the properties that are related to specific environment? When you are deploying a certain region, how it will happen? So it will happen in this way using a profile concept. Profiles is the concept. For each region, you can actually define a separate profile configuration file, and when you are deploying it, when you specify or mention that in Jenkins file, or when you are deploying or running the application, you have to specify it. So that way it will fetch the respective configuration from external, mm, from uh, repository, yeah, using external configuration. So profiles is for differentiating and segregating the environment, different deployment environments, and it would be helpful to trigger or invoke the respective configuration file, property file. So next thing is that Spring Data JPA. Spring Data JPA is a very good thing for dealing with the Java persistent API. Nothing but Java persistent API. It is a very good framework for dealing with the data layer because it is an abstraction. You know, um, as part of Spring Data JPA, what you can do, you can simply utilize the starter dependency, Spring Data JPA starter dependency, and after that what it happens, you can actually create interfaces of repository interfaces, in which you will provide the table name, entity name as one parameter, and this key is unique identification key, primary key or unique key. These two parameters you will pass that in the repository interface, and from there, by default, it will have all the inbuilt methods for fetching data, for updating data, for saving data, for deleting data. It will have all the default methods. Or if you want to customize it, you can also customize it. And there is a concepts for paging and sorting concepts, where sometimes for user interface we may need to fetch only 100 rows at a time, not all the records. So we can also specify the page size. We can also sort the data that is being fetched um, to the client. So these things we can achieve it. Spring Boot framework is providing all these features and concepts there. So this is also one of the good examples for dealing with the Spring Data JPA. Other thing is Spring Data JPA. You can configure multiple data sources at a time. You can configure, SQL database, NoSQL database. You can create a separate configuration files, data source configuration files. You can utilize it. You can also deal with the NoSQL database. Not only that, for any database, Spring Boot provides adapters, dependencies. If you have that dependency, simply include that in your build file, form.xml, and then you just write your repository interfaces. Okay, uh, So that way you will map the data to object directly to entity, whatever the entity that you are going to utilize it, and it will do the auto serialize and deserialize. You don't need to do that extra. Additionally, everything is inbuilt. You can avoid the boilerplate code. Most of the boilerplate code can be avoided. And recently, with the Spring Data JPA, some Lambda, the um, Lambda features are introduced where you can simply specify some annotation at the rate data, at the rate, if you specify at the rate data, at the rate setter getters, you don't need to create any setters and getters. You simply create a pozo and required field, that's it. It will create all the required constructors, required the setters, getters. It will do everything. So the code will look like plain and very simple and understandable to the developer. So that is an example. Um, okay, I got it. So other thing is external configuration. We already discussed the Spring Data GPA. Embedded server is one of the good example. We already discussed about it. I forgot one of the thing. What is that? Profiles and Spring Data GPA, and we have actuators. So actuators is one of the concepts. See, once you build an application, you have to monitor the application, right? So you have to monitor the health, you have to monitor metrics, you have to see all the details. So how do you do that? So actuators is one of the features provided the Spring Boot, where you can actually see all the list of endpoints. You can do that. You can actually integrate the Swagger also, where it will display a simple user interface page, HTML page, where you can see all the endpoints that are related there. Using actuator, you can access and you can see environment variables. You can change the environment variables, and you can see the health of this endpoint server. No, the basic required monitoring health metrics. You can see with the help of actuators. It is a very good example of the Spring Boot features. So Spring Boot along with the Spring 8, Java 8 is also the combination is going to be used as part of the development nowadays. Most of the companies, all the companies, Spring Boot and Java 8, they are using more than Java 8 version. Whoever is well aware of, because Java 8 is providing a lot of uh, features, streaming features, data, lambda functional programming. Functional programming, the help of functional programming, it reduces the lines of code, the simplified into single lines. You can do most of the thing using a single line, right? Even data processing, data streaming related logic you can implement using a Java 8. So these things you can actually achieve using a Java 8 and with the Spring Boot framework. So that is why the companies are preferring the candidates who are having the knowledge. Uh, Spring Boot along with the Java 8 are more than uh, Java 8. I mean, whoever uses Java version more than Java 8, they are preferring the candidates. So that is the important thing. Yeah, so other thing is Spring Boot is getting advanced every day. They are actually giving a pre-built options, many options. They are adding boilerplate code, and along with this, Spring Boot is coming with many other options. You can integrate whereas Spring Cloud also you can utilize it for building microservices and all. And all these options are available. You can actually go through the document of the official website. You can see the documents, how the Spring Boot is going to do and everything. Uh, so other thing is Um, uh, Microservices is one of the concepts where, with the help of Spring Boot nowadays, so many companies and they are moving their core applications to microservices architecture, including banking and other business domain related applications are getting converted into microservices architecture as they are utilizing this Spring Boot framework for building microservices. That is the major use case we can see that there. And as I told you, for a user interface, also, for building user interfaces, so many JavaScript framework are coming into the market. You can see React.js is the latest thing. Earlier we have AngularJS, which provides model view controller, and Next.js, Vue.js. So many JS frameworks are coming into the picture. You can beautifully design the user interface. And the other thing is for asynchronous kind of programming. So for backend also, you can backend also. So for backend framework also, you have multiple frameworks are coming in Spring Boot, event-driven type asynchronous based. This callback using this callback concept. They introduced Spring Web Flex or something. You can actually create a backend code also for frontend. Also, React.js is one of the examples. So for messaging, for building event-driven architectures, so we have many messaging softwares like uh, messaging queues, Kafka, and Cloud Data Stream or RabbitMQ. You can utilize any messaging softwares. So that is also one of the they are very good examples for building uh, event-driven architectures. Because what do you mean by event-driven architecture? Say, let's say tomorrow you want to publish a notification asynchronously. See, the synchronous part is when you are calling service B from service A. Service A has to wait until the service B provides the response. So, if you are invoking utilizing some third-party service, it has to wait for the response until the third-party service or API gives the response. But asynchronous thing is sometimes you may have a requirement. You want to trigger a third party service, but you don't need to wait for the response. You just have to trigger it by sending a message. That's it. For example, triggering a email, sending a SMS. So the recipient may definitely get that, but after for some time. So it does not affect the. So SLA is not a matter here. But the thing is delivery of the message asynchronously. Imagine if the crores of messages, millions of messages, millions of uh, mails have to be delivered in a less time. Then synchronous approach is not a good architecture. Then we follow asynchronous architecture. Um, that is a very good thing. For that, Spring Boot is supporting asynchronous. You can actually integrate third parties messaging software with the Spring Boot. You can do that. You can actually publish the messages. You can write the producers. You can also write the consumers. Using a Kafka template, you can actually publish. So many new keywords are getting implemented. New features are implemented for asynchronous also. You can smoothly publish messages without any issues using callback mechanism, and you can actually consume the messages also. You can build complete end-to-end enterprise grade messaging system, event-driven architecture using Spring Boot and messaging services. So that is a very good feature along with the Spring Boot, and we have many others, features also. we're talking about NoSQL databases, so MongoDB, Cassandra, HBase, GraphQL, so many NoSQL databases can be integrated using Spring Boot also. That is also one of the example. And other thing is with the Spring Boot, the API generation, API creation is very simple. It is providing lot of annotations. You just have to utilize those annotations, avoid the boilerplate code. It is very simple, right? You take it from the controller and service and repository. And repository in the repository section, you will map your entity, and you that will be automatically map to data sources. The data sources, you will specify the data source details in the configuration properties file, or you can create a config objects also if you want, right? You can do all these things in your application. So that way you can utilize the uh, Spring Boot, and the API creation of API, as I told you, is very simple. And you can also create a multi-modular project also. So this is an example. NoSQL databases and Spring Boot and GraphQL is one of the things I want to explain here. Earlier, we used to get the data from the table, right? Let's say the table is having 1 million rows. So if I want to fetch the 1 million rows for a single request, so it may take a lot of time. So response times on the data layer should not be more than 1 second, right? It should be in milliseconds. See, if SLA is showing a data uh, on a user interface is a key thing. So then client may mandate an SLA at least 2 seconds, maybe not more than that. When the request is submitted from the user interface, client may wait until up to 2 seconds or 1 second. If that is the case, then we have to split the response time. So how much time the data layer should take, how much time the middle layer should take, how much time the user interface should take, and to render the data. So if the data layer is itself is taking more time, then it will breach the SLA. Um it is not expected scenario in the business point of view. So they will disagree on this. So that is why when you are designing a data layer, it has to render the data within milliseconds. So that is why that is where the GraphQL brought a new idea where when you are fetching a data, sometimes the table is having million records. It will fetch all the. Why do we need to fetch all the records? We can only fetch the records that are required, right? Not all the records. So GraphQL, what this GraphQL will do, it will simplify the process of filtering. Uh, you will only fetch the only required attributes, not all the attributes, right? That way, if you integrate the GraphQL, when you are sending a certain input message from the API for the API, so it will render the only certain attributes. Now you don't need to display all the attributes in the output response object, JSON object. Okay, using this GraphQL, you can customize, you can modify the things. You can check that out later. How the GraphQL can be used and how it would be so useful and all. And the Spring Cloud is also playing a vital role now. Spring Cloud, so many options. Spring Cloud Eureka Server, Spring Cloud configuration. So, Spring using Spring Cloud for building a microservices, many features are pre-built actually. So you can utilize the Spring Cloud for designing a microservices architecture very easily. Okay. So in this way, we for supporting Java, so many Spring Boot frameworks are there. I hope you understood these features and concepts. Thank you for listening and thank you for the video.